This is high-tech electronics Pune make pulse position modulation and demodulation trainer kit. So we will start performance of this trainer kit and we will go step by step. Before that I am switching on the kit, and we have provided inbuilt sine wave generator and triangular wave generator. We will check first the waveforms. This is frequency and this is amplitude. Now we will check triangular wave. Frequency, amplitude. Now we will start performing the experiment step by step. Now I am connecting this triangular wave generator input to PWM section mark B and sine wave input A mark A. Now I will observe PWM output. I am connecting ground and PWM output. For this to observe, we will connect both input and output, means sine wave to one channel and PWM output to another channel. So I am connecting sine wave. Ground is already connected, so I am not connecting the ground. See, you are observing the PWM output at positive peak of the sine wave. You have maximum pulse width and pulse width goes on decreasing. This is what PWM output. Now I am connecting PWM output to delta pulse generator D, and I am connecting delta pulse to comparator input. If you want, you can observe the delta pulse generator output, but it is not required. This is just for information. Now to get proper ppm output, you have to give external DC power supply. So I have connected this power supply. I am connecting ground to kit and external power supply at this point. Now I will observe ppm output. So you have to observe ppm output with respect to PWM. So I am now connecting this to PWM. See, here there is pulse position change for every positive to negative going of PWM output. So this is ppm. You can adjust little bit by using this power supply. See the effect of power supply. You can observe here clearly by pressing the run stop mode of the DSO. If you are not able to observe clearly after auto triggering, you have to run stop this and then observe the signal. Now this PPM modulation part is over. We will move to demodulation. Now I am connecting this PPM output C2 to here, C2 marked. Here alternator is used because the amplitude of this signal is high, so we have to alternate to get the proper output. And here at the chopper input you have to apply sine wave marked A and marked here A. So I am connecting sine wave. And now I will be observing PM. This is a step-by-step circuit design and checking for this PPM demodulation circuit. Now I will observe this now sine wave here instead of see here you are getting before this you are getting this noise or unstable waveform, so I press this one, you are getting stable waveform. So here PM output we have observed. Now we will go to next step of recording the signal, demodulated signal and wave shaping of the circuit. So I am connecting this PM output to C5, here mark C5, here also mark C5 to wave shaping circuit, and I am observing record output. So little bit recovery of the signal is there. And now to remove the remaining noise, I will connect this record output to filter. And I will be observing the output as final output of PPM demodulated circuit. See, you are getting here original sine wave as well as demodulated output sine wave, and I am verifying this by varying the frequency and amplitude of the signal. See, I am varying the frequency of this sine wave, the frequency is getting varied. Along with that, amplitude changes because as frequency goes on decreasing, amplitude increases, and as frequency goes on increasing, amplitude decreases. This is a normal phenomenon of any amplifier response. And here is the amplitude. So this way we have performed PPM modulation and demodulation trainer kit experiment. Thank you very much.